So, to the audience, please be introduced to Visit Thaveep, Managing Director at Zensorium, tuning in from Thailand at the moment. Am I right?
Actually, I'm in Japan right now.
Okay, you're in Japan, and Visit will talk about advances in PPG wearables from racial bias correction to novel digital biomarkers. Visit, the stage is yours.
Thank you. So, I guess good morning, everyone, or good afternoon. Um, so, what I like to talk about today is our core activities at Zensorium. We are part of the family of Nitodenko Corporation, which is headquartered in Japan. We have two offices, one in Singapore and one in Bangkok. So, for wearable technology, I mean, as most of you are aware of, that today the device is really everywhere. And the boundary between it being a medical device and wellness is just really blurred at the moment. The manufacturers, although believe that mainly focus on the software and AI, want to process large amount of data, want to improve more algorithms. But we think that few are actually focusing on the fundamental, the sensing technology. It's more applying based on the signals that they derive using mainly the heart rate and the motion as the main core parameters. And with that, we think that this technology is still in its infancy. I'll show you a few examples here, and there'll be more opportunity for us to discover new clinical findings and practices. So start off, just a touch on the PPG mouthful. The word is actually from photoplethysmography. Essentially, it measures the change of the blood volume in tissues. That's in the back of most of the wearable device today, the green LEDs, or even in the pulse oximeters, that also the same technology as well. But most of the time, people derive just the heart rate itself, which is the timing analysis of the pulse. Below there, you probably can see a little wave form that I draw. Usually, people just identify the red dots or the peaks, or could be the valleys as well. By doing that, it's quite simple for you to do. What you can get is the heart rate or the heart rate variability from the PPG signal itself. In our case, we took the entire pulse shape and we analyzed that. And one of the key features that we've been exploiting is the pulse pressure. I mean, certainly we're trying to target the systolic, diastolic, and the absolute blood pressure, but at this moment, we still need to do quite a bit of calibration, and thus we just focus on the differences between the systolic and diastolic, which is the pulse pressure. And we found that we can track that very well and very consistent. So let me touch on the pulse pressure a little bit. The pulse pressure, as I mentioned, is the difference between systolic diastolics, although it's not a parameters or features that the clinicians utilize it today in practice generally, but there are really plethora of articles and research that talked about its importance, in cardiovascular diseases and hypertensions, understanding. In fact, in some of the studies, talk about these pulse pressure being even more important or relevance parameters than in terms of understanding hypertension and CVD than the systolic and the diastolic itself. But essentially, this pulse pressure has it relates directly to the arterial stiffness, and it increases with age as well. So we certainly explore many different parameters. We currently very interested in mental health application, sleep apnea, kidney health, CVD and stroke. those believe that four parameters that the wearable technology